Yes, sir. Folks, we'd like to recognize Mr. Ordia. And he has a great presentation for us tonight. Just you can check out, he's got a nice looking solar panel right there. And I'm going to go ahead and turn this meeting over to him. Thank you.
Thank you. Thank you. Good evening.
Would you like
Can everybody hear me all right? Yeah. I'll just go ahead. So my good evening. My name is Joe Ordia. I'm the president and co-founder of PEG Solar, and we are an emergency preparedness company focused on off-the-grid power systems, particularly solar power systems. So today we're going to be talking about this topic here: are you prepared for grid down? Talking about why it's important to have an emergency power plan and how renewable energy and solar power can fit into that plan. This is actually the first time I've been back in this building since I took my technician's license test 3 years ago. And I actually remember a couple of faces, so I think it must have been my exam proctor. So it's good to be back. Thank you for the invitation.
What'd you call?
KK4WPO. All right. So, thinking about threats to the power grid, our modern lifestyle, we've become so accustomed to always having technology, power, and communications available to us. I used to be a contractor for the Army, and I know that when we go and attack another country, the first thing we do is take out the power, take out the telecommunications, lock down transportation. And so when I talk to folks about being prepared and being prepared for catastrophic events, you need to be prepared to hunker down at your house, provide your own power supply, provide your own communications, have enough food, water, and supplies to sustain yourself and your family. So power plays a big part of that. Just by a quick show of hands, how many of you all are on your own well and septic system? Okay, so I am too. So if we lose power, we don't just lose the ability to watch TV and have air conditioning, running water, the ability to flush the toilet, all of that relies on having a power supply. And in today's world, cyber terrorism or threats of terrorist groups or sabotage agents, our power grid is very vulnerable to attack. Not to mention more routine events like extreme weather, any number of things. A tree falls down, knocks out power to your neighborhood. So all these things have the ability to really impact our lives in a very negative way. And so what our company is all about is helping to empower families that they can sustain through these type of emergencies using renewable energy that they own and that they control on their own property. Again, just to drive the point home, we depend on energy not just for lighting, but for heating and cooling, for food preservation, for medical devices. Anybody here uses a CPAP machine or oxygen machine? Okay. So all that requires power, not to mention our computers and cell phones and gadgets and all those creature comforts. So power isn't just about every part of our life. And as I mentioned, we started out as an emergency preparedness company, offering people advice and services in all areas of preparedness. But the energy part is the real part of the business that really took off, because what we've come to understand is energy powers all of those other things. So why solar power? Well, number one, there's no counterparty risk. You're not dependent on, or you not necessarily have to be a partner of the power company. You can invest in your own renewable energy generation off-grid, or at least with the ability to run off-grid in the event of a utility outage. So you can control the means of production. There's little or no operating cost. Once the system is up and running, that system is going to continue to harvest, store, produce energy that you can use day in and day out. Unlike a generator that requires constantly being fueled, routine maintenance, moving parts that break down, so on and so forth. Also, it's completely discrete. So for those of you that value privacy, discretion, the solar power system is completely quiet. Once it's up and running, nobody has to know it's there, and it's going to provide secure, clean power to your home. And so for all those reasons, I believe solar is really the killer app, so to speak, in terms of self-sufficiency on your power supply. And just to let you know, before we ever got into the business of doing this for people professionally, we installed an off-grid solar power system in our own home. And you know, like some of you probably, I like to build things, and I like to know how stuff works and tinker around. And so I ordered a couple of solar panels off of Amazon, got a couple of batteries at Sam's Club, and a controller that I ordered off of eBay, and just kind of figured out how to wire these things together and how it works. And so I'm going to talk about a little bit more in detail how some of the components work and the technology behind it. But this is something that we believe so strongly in that we decided to make it our business. So that's how we got to where we are today. All right, so how does it work? The first part of the system is your solar panels, or what's called PV panels, photovoltaic. Their job is to convert sunlight into electricity, flow of electrons. Solar panels operate on direct current, so they're a constant voltage source, and they come in a wide variety of sizes and voltages. Like these panels here, these are 60 watts each, and they operate at about 18 volts at their maximum power point. So that 18 volt DC voltage source can be used to charge or operate 12 volt, nominal 12 volt equipment. And so that's typically what you'll see is the rated voltage on the solar panels is slightly higher than the DC battery system that you're going to be charging with. Anyway, that DC power flows down usually into a bank of batteries, which serves as your energy storage. Whatever energy is not going to be consumed or used right away by your appliances or loads gets stored in a bank of batteries, so it can be used at nighttime or during periods of cloudy weather. And then that battery bank is also tapped to a device called an inverter. An inverter is just a special type of electrical transformer that not only steps up the voltage, but it converts from a constant voltage to an alternating current, or an oscillating voltage. Now once you have AC power coming off your inverter, that can be connected to your house panel for selling back to the power company, or it can be connected to an emergency panel for powering your essential appliances during an emergency. So basically, once that energy comes out, 240 volts AC off of your inverter system, it is just like any other AC power source, like a generator or what have you. That power can be distributed to any circuits or any piece of equipment that you need within the property. And then, like I said, in the case of some systems, you can even sell the excess power back. If you don't need it, you can sell it back to the power company to earn credit or to zero out your electric bill. Any questions so far? Yes, sir.
In the case of an EMP, how subject to damage is the inverter and the cells themselves? And also, that's the main question.
Yeah, I get this question a lot. So the question is, in the event of an electromagnetic pulse, how vulnerable are these various components to attack? The answer is that the inverter is the most sensitive of all the equipment. Anything with solid-state electronics, microprocessors, the sensitive control circuits that run these, big transformers, all those things are very, very vulnerable to that type of a power surge. There's also one other piece of equipment that's not depicted here, but there's a regulator, or what's called a charge controller, that actually goes in between the solar panels and the batteries, prevents the batteries from being overcharged, and it allows it to kind of tune the voltage for optimal battery charging. That piece of equipment is also very sensitive to a power surge or an EMP.
What about motor starting loads? Are the inverters designed where you can start your air conditioner off of it?
Yep. So the newer inverter systems that are designed for home backup, which is most of what we do is home backup systems, they have a huge capacitor bank with a large startup surge. Typically, they can sustain a load of 12,000 watts for 5 seconds for starting up large motors like an air conditioner compressor or a well pump for that matter.
Are there different types of inverters? Are there some that produce more of a pure sine wave as opposed to others?
That's a good question. I'm going to jump ahead a little bit here and kind of talk in more detail about some of these components. So the inverter is really the main engine of your renewable energy system. This is it's pulling in DC power off your solar panels and batteries, right? Or also could be charged by a windmill or a water source. And it's converting that into, usually it's 240 volt AC power, which is what most US residential homes are wired for. They come in what's called a modified sine wave or a square wave inverter, which is basically, it's a transistor-based kind power, or you can have what's called a true sine wave, which is an oscillator transformer based. Basically, it's clean power, the type that you would get from a utility or from a high quality generator. All that we do right now uses what's called the true sine wave, which is that cleaner, higher quality power. And the reason is because supplying the wrong type of power to sensitive equipment can permanently damage that equipment. Microwaves, audio, video equipment, medical devices, laser printers, none of these things work properly with that lower cost simulated, or what's called modified sine wave. So we want true sine wave power, smooth oscillation up and down.
So what's the typical efficiency you're seeing with the true sine wave inverters in the market?
The good inverters now will give you between 88 and 90% conversion efficiency.
Because I thought it was 80, so I'm glad to hear it's higher than that.
Yeah, 88 to 90 is, probably the going range. And we don't really use the lower price stuff. So I know that, maybe 80% for more generic stuff, but, I've been doing this long enough now. One of the lessons I've learned is, it might be cheap today, but 6 months from now, when the customer calls you back to fix it because it's broken, it ends up getting expensive very quickly. So, if I can give you any advice for you to do-it-yourselfers out there, invest a little bit more up front, get the good U.S. or European-made equipment, or at least U.S. European companies backing it.
So what do you do with excess voltage coming down from the solar cells to prevent them from going to the battery, to dump it into a water heater, like they used to do in the old days, or?
What you're talking about is a dumper,
Yeah.
right? The modern charge controllers actually have the ability to transform the voltage coming off the solar panels to whatever the optimal battery charging voltage is. So it's not uncommon for a system that we do for home backup to wire the solar panels at an operating voltage of about 100 volts per string, running into what's called an MPPT, a maximum power point tracking controller, which will then step that voltage down to either 14 volts in the case of a 12-volt battery charge, 28 volts in the case of a 24-volt battery charge, or about 55, 56 volts if it's a 48-volt battery bank. Most battery banks for home backup are at 48 volts DC now. However, I understand a lot of ham equipment is designed to operate mobile at 12 volts. So if you're looking for a solar power system just to run your mobile radio equipment, you don't even really need to worry about the inverters and all that other stuff in that picture. A small solar panel array, a small controller, and a 12-volt battery will actually get you, an emergency power station that you can use to communicate. Because if the grid does go down and we have a major type of event like this, you all are going to be the new cell phone company, right? I mean, that's going to be it. So I do think, if you folks see yourself as a community emergency resource to be able to provide communication, think about maybe having a renewable energy backup system. It's really not very expensive at all. And I was saying, we actually have a lot of scratch and dent and spare parts at our shop that we can use to help you, if you want to kind of do it yourself, piece together a system that you can use to at least power your radio. Yes, sir.
What about radio hash and noise from all these inverters and everything?
That's a good question. I have seen where the inverter causes interference on certain AM radio stations, not FM, but on AM. To be honest with you, I don't really understand the science behind it, why there's interference in that range, but I have seen it on AM stations.
Well, most of them use an oscillator, like 25 to 50 kilohertz oscillator, to basically up the voltage, and I think they get a lot of harmonics from it, which is where we get the noise from. I've heard some charge controllers make a lot of noise and some don't. I don't know.
Yeah.
Have you have experience with it, right?
Yeah, mine makes horrible noise, but if I really want to use the radio during the day, I just pull the fuse and go ahead and run off the battery.
Okay.
Real simple.
Yeah, and I guess it probably depends on the charging algorithm as far as how that electricity is pulsed into the battery. The main oscillator on the inverter should be running at 60 hertz, which is
right.
What our utility frequency is. So in theory, there shouldn't be interference there, but we do see it sometimes. Yes, sir.
Oh, Malin, I'm curious as to how close the charge controller is to your radio. Is it all in the same room, or is it on the other end of the house?
It's in the same room. It's putting it right on the battery leads. The noise is right on the battery.
Okay.
And You think the battery being a big capacitor might take filter some of that out and put it in wall. It's just a cheap charge controller. And, I was talking to him about it, and maybe I'll get around to trying another one, but, with being a ham and low budget.
Reality.
And by the way, some of the premium manufacturers are putting out high quality, they're low output but high quality charge controllers in the $99 range now. Now you'll only push 20 amps through them, but that's probably enough for your mobile battery.
Yeah, I have a question about charge controllers and bulk charging. You say it'll adjust voltage and everything on the fly for that sort of thing. Is that typical?
Right, and you can typically program them for different types of batteries. So depending on your battery chemistry, let's take a typical flooded battery. A typical flooded battery, 12 volt, you're going to charge it at 14 and a half. And then you're going to kind of float or cut off at that point. An AGM battery, you might charge at a slightly lower voltage, so you don't damage the glass mat inside the battery. So all that can be programmed into the controller. Typically, you'll go to bulk charge up to a certain threshold, and once you hit that threshold, it's constant voltage and the current tapers off so that voltage never goes above that threshold, and then you might drop to a slightly lower floating voltage once you've gone through the full charge cycle.
So it'll handle self-discharge.
Yeah. Yeah.
When this is not in use, does it have like a tender that keeps it at the battery at a certain point?
Yeah, well that's one of the functions that the charge controller performs. So it'll give the battery like a daily maintenance charge, right? Keep the battery within healthy operating voltage based on the battery chemistry. And then depending on what type of inverter system you have, it may invert the extra power and sell it back to the power company, or it may just invert only what's needed to power the loads inside your house. So there's a lot of ways that we can do this. Let's see. Just a quick discussion about batteries. We already talked about sort of different chemistries and different types of batteries that are available. Your typical wet cell battery, or sometimes also called a flooded battery, is probably what you see in most applications. It's what's in most vehicles, what's in most electric golf carts. They offer the lowest cost per unit of energy stored, and they also do last the longest if you take care of them properly, don't overly discharge them, and do the routine maintenance charge or equalization charge on them to keep them healthy. So they offer lower cost, better longevity, but they do require some maintenance to get that performance out of them. We also have what's called an AGM battery, which stands for absorbed glass mat. The AGM batteries, the electrolyte is actually immobilized in a fiberglass mat inside the battery, so it doesn't slosh around. These are very popular in boats or places where the battery may, be tossed around or has to be placed on its side. They're also much safer for use indoors because they don't have the problem of off-gassing hydrogen as bad as the flooded battery does. Flooded battery pretty much has to be used outdoors or in a container that has direct ventilation outdoors, so you don't have that hydrogen gas buildup. The AGM batteries also do give you slightly better charging and discharging efficiency. So more of what you charge in, you're going to get out of it. However, they are not as durable as the flooded battery. So it's not going to last you as long. Typically what we find is that for standby applications where the battery is only used in an emergency, the maintenance-free sealed AGM batteries are the way to go. It's just, nothing to think about, no real headache, no extra chores for the system owner. For people that are 100% off the grid, they typically go with the traditional flooded battery. And if you're an off-grid or 100%, you're already used to doing a lot of chores and kind of knowing how to take care of yourself. That just becomes part of the routine. Sir?
Is there any advantage, disadvantage to gel cells? I know she had mentioned that.
Yes.
We do.
I guess before the AGM batteries came down in price, gel was the option of choice for marine applications or applications for indoor. To be honest, I don't really see many gel batteries on the market anymore. It's mostly either the flooded or the AGM, or what's now coming out is the lithium-ion batteries. And so we're actually an approved installer for the Tesla Powerwall. I don't know if you guys are familiar with Tesla, electric vehicle company. And so they actually have a home battery product that we're going to have available here within about 2 weeks that you can actually use to be your home backup power source. in place of a traditional generator.
What's the cost differential between this and lithium? Is it 2 to 1, 3 to 1?
It's about 4 to 1. It's about 4 to 1 standard battery versus a lithium battery per unit of energy stored. However, the lithium battery lasts 4 times as long in terms of number of cycles. So it's kind of like you're paying for it up front, but the lithium battery is going to last more, more cycles.
Sorry, I gotta ask then, if you're talking lithium ion, how does it handle the heat buildup when you discharge? I mean, I assume they've solved that.
Yeah, they've integrated the heat sink and the battery pack and the inverter in one little appliance. I mean, it literally looks like just a panel that you hang on your wall. You run it to your electrical panel, and they've integrated all that.
One of the problems I ran into with my home generator was that the battery kept freezing and going dead. If you use the lead acid batteries, you have to build a special enclosure with heaters to keep them in.
That's a good question. So, if anybody didn't hear, the question was, if you use traditional flooded batteries, do you have to put some kind of a heating system or climate control to keep them healthy? It really depends. In areas that have extreme cold, it's very important that the batteries are somewhat climate controlled. I'm talking about places like Alaska or the Dakotas, things like this. Here in Virginia, where we generally don't see temperatures much below the freezing point, we've put systems in where the batteries operate outside. And yes, there is a performance hit when they're operating in very cold temperatures, but it's not a necessity that you have to climate control it. Ideally, though, if you've got the space and you're willing to tolerate it, having a sealed battery inside the home that can take advantage of the home's climate control is going to perform better for you. So, any other questions about batteries?
The average price, say, for a fairly decent deep cycle battery, I know there's all kinds of applications, but the average price is...
So, the average price for a standard 6-volt deep cycle batteries is about $100 a piece.
Okay.
You can buy them at Sam's Club. It's actually where I bought my first batteries, at Sam's Club, before we actually got into selling these. The AGM batteries are going to run you about $160 to $200 a piece for the same capacity.
Now, you were talking about enclosures. I guess if you did keep them outside near the house, you keep them in some sort of a well-built wooden storage cabinet.
Yeah. So
Because you're not supposed to set batteries on metal or anything like that, correct?
yeah, oftentimes what we'll do for larger battery banks is we'll build an enclosure adjacent to one of the exterior walls of the house. And so we'll actually frame it out, just like you're framing out an addition. We'll put siding on it, and then we'll put 1-inch foam insulation inside to provide some thermal insulation. And then we'll just run a conduit between the box and wherever the inverter is placed to bring the conductors.
Now, how would that be connected through a transfer switch if you have one? From your generator, transfer to the main panel? You're talking about two different systems, correct?
Yeah.
Okay.
So it's what's called hybrid inverters. The hybrid inverters that we install for home backup act as a 4-way transfer switch, where you have AC from the grid, optionally you have AC from the generator, you have DC from the battery, and then you have DC coming in from your solar panel array. And that inverter can switch between or even have multiple of those power sources running concurrently based on how you program it.
Now, my application would be basically the same as Malin's and maybe other folks in here. I'm not as much concerned about the whole house as I am a CPAP, the radio equipment, and maybe some small lighting.
Right. And so that's why we have what's called the critical loads panel. As opposed to trying to power every circuit in your house, what we'll do is we'll identify the most critical circuits.
Okay.
We'll move them to a smaller panel, what we call a critical loads panel, or sometimes an emergency panel. And we'll have the inverter system just wired to power this on battery backup. That way you don't need so many batteries trying to run everything. You have just enough to run whatever for you is your critical requirements. And then if you want to expand the system, we can always add on to it from there.
All right, because my transfer switch is just strategic, freezer, refrigerator,
Right.
well, that sort of thing.
So it sounds like you already have a critical loads panel.
Pardon?
It sounds like you already have a critical loads panel that, as part of that transfer switch.
It's a transfer case.
So in the transfer case, and there's some individual circuit
Yes,
breakers
yes.
underneath it. So those are the critical loads.
Yes.
And so we can wire the solar system, again, just to power those same critical loads.
Okay. Oh, okay.
You know, and to allow, when the generator is running, to power those critical loads and to recharge the batteries. So let's say we get into winter, you've got a week where it's all cloudy weather, your solar panels aren't producing much. You fire up the generator for a few hours, charge your batteries back up full, then you switch to running off batteries for the next few days. It helps you save fuel and, you know, extend that running time without breaking the bank.
One last question. This is probably unfair, what would be the basic cost from what I'm talking about, the basic 4, 6, or 8 of those panels set up not on the house or on my garage, but outside?
So a basic setup to run, like, let's say you just need the well pump, the fridge, and some lights, and the CPAP machine. A basic setup like that is going to run you about $6,000 if you have us install it for you, or if you just need the parts and can do it yourself, it'll run you right around $3,500 to $4,000. Now that's just to run your essentials. If you want to run the air conditioning and the stove and all that other stuff, you might be looking at more of a $10,000 to $12,000 investment.
I understand.
But the prices are coming down to the point where it's almost comparable to getting a professionally installed propane generator. You know, with the advantage of this is it's renewable, there's no fuel requirement, there's no engine maintenance, there's no moving parts. So once you've got it, you know, you're self-sufficient. And for months at a time if you had to.
Okay.
Yes, sir.
Is there any code restrictions as far as being able to take and put the batteries in a crawl space or basement if you could properly vent it outside, considering that is a more controlled environment?
Yeah, so if the square footage of the area that the batteries are placed are not large enough, based on the size of the batteries and the size of the room, then we would have to do a dedicated ventilation. Essentially, the batteries have to go in a cabinet with a dedicated vent line to the exterior.
Does it have to be a power vent line or just like an ambient vent to go out and carry the gases?
I have not seen any code that requires a powered vent, but there are powered vent options as well that'll run right off the DC power source. Yes, sir.
There's several companies working on solar shingles. You're aware of those, I assume?
We are. They haven't come to market to the point that we're ready to sell them or install them for you, but it is something that we would like to offer when they're ready for prime time.
Because with that, you literally, so right now I have, the old 25-year shingles, right?
Mm-hmm.
So you're gonna rip those off and the whole top of your house is gonna be a solar panel?
Well, they would be individual solar cells built into the shingles with some bus bars basically underneath where the shingles interlock. And then we can tap onto those bus bars, and then the rest of the system design is pretty much the same. You feed into a charge controller, which then charges a battery bank, which then feeds DC to your inverter system.
Okay, so let's say we already have, let's say tomorrow I ask you to add a system to my house, and then 2 years from now, those shingles become available. What I have now can just be tied into it?
Correct.
Okay.
The battery, the inverter, all the critical loads, and the transfer switch, all of this can stay the same. You're basically just connecting a different PV source in for battery charge. So yeah, it's a really interesting time to be in the industry. When I first got into this was very much a fringe kind of thing. There were very few people investing in home battery backup systems. 5 years from now, this is probably going to be a common thing where, talking what kind of battery do you have in your house? Well, now you know what kind of battery I have. It just makes sense. Yes, ma'am.
Are there any companies that are in the lease market for the panels themselves? All the other stuff, all the guts of it has to remain with the building, but do people anywhere in the country do leasing of panels?
I've heard of leasing complete systems.
The whole system?
Yeah, and then there's also financing for the complete systems. Lenders like to lend for solar power because it creates cash savings in the form of not having to pay an electric bill. So they've got programs where you can do unsecured loan out to 7 years, or you can secure the loan with the system being the collateral out to 20, 25 years. And so a lot of folks basically look at it like, hey, I'll trade an electric bill for a solar loan payment, and then once I pay off the loan, it's like having free power. Yes, sir.
I think she was more asking like, take it with you when you go. Is it easy to do that, to take it to another house?
It's possible. It might work out economically. It's better to leave it behind. Let whoever's buying it not have an electric bill, and then reinstall a new system. But no, I mean, there's nothing to say you couldn't take it with you. And I know I had one case where the guy, we had to take the system down. They were demolishing the house and building a new house on top. So well, it can be taken down if needed.
What are the county permitting requirements for this?
So in just about every county, you need to get an electrical permit because you're going to be modifying the electrical system of the house. You're going to have an electrical permit. You have to submit your electrical wiring schematic or called a one-line diagram, just showing how the system is going to be interconnected and overcurrent protection and all that stuff. Many jurisdictions now are also requiring us to get a building permit as well, which means that we have to have a structural engineer certify the plans, do a load analysis on the roof to make sure that with the additional weight, it's still going to meet the weight requirement, that it's still going to meet the wind rating and all that stuff. So a lot of times what we'll do is we'll just kind of send over our basic design from our system designer to the professional engineer, and then he'll break that down into very detailed building plans that we can send into the county.
What about homeowner restrictions?
Homeowners restrictions?
Yeah, homeowner associations.
So it depends neighborhood by neighborhood. The way the law is written in Virginia, the homeowners association cannot restrict your right to solar power, but they can provide guidance as far as what side of the house it's on, what color panels to use. So they can provide aesthetic guidance. They cannot restrict your access to solar.
What about having a cutoff for the panels themselves? You know, if you're worried about a fire or something, I've heard that's been a little bit of an issue too with fire departments. They're worried about,
Yeah, so
you know, the panels themselves being up there, they would overheat and fire.
starting with the 20, so just anybody here, the question was, are there any like disconnecting requirements that you have as far as for fire safety? Starting with the 2014 National Electric Code, any system that touches the utility grid has to have what's called a rapid shutdown, which means that if utility power is lost here, because that's typically what the firefighter will do, is they'll just pull the meter out to make the whole house dead, that the DC power needs to be disconnected back to within 10 feet of the PV array, so that they're not there swinging with axes and saws and they hit live DC conductors, and then you can have a real problem there. So that rapid shutdown requirement's been there since the 2014 code, and most jurisdictions have adopted the 2014 code now.
How is that done, though? How is that done? I mean, if you pull the meter out, to the system, that could look like it just lost power, from the regular supply from the lines.
You'd have to placard it, that's all.
Yeah, you have to placard it, and there are some disconnect switches.
Oh, so it doesn't do it automatically?
No. So a couple of things. The rapid shutdown requirement is an automatic requirement. So for grid-connected systems, I'm not talking about battery systems.
Right.
For grid-connected only systems that don't have the battery or the generator, as soon as this grid connection is lost, they've got to disconnect power all the way back up within 10 feet of the panels. Battery systems are a little bit different because battery systems are designed to be a backup power source. And so even if utility drops out, you still have power energized in to your critical loads here. But there are labeling requirements, like you said, you have to kind of identify where all the power sources are and where the disconnecting means are. And it's got to be on a red and white placard that says games.
In weighing this technology against, say, a generator, generally if you're going to have a power loss, it's going to be either somebody hits a pole on the street or it's going to be during a storm, like a snowstorm. If you get snow buildup on the roof, like we had last week, I mean, I had 8 inches of snow on my roof. What does that do to the collectors? Do they not function at that point?
Yeah, they barely function. If you're not getting direct sunlight, or at least diffuse sunlight to the solar cells, you're not going to have much energy production.
So if you really wanted 100% backup, you need a
You
generator.
need a generator, yeah.
Oh,
And that-
room.
For a home group, yeah. I mean, I've got both, so I've got solar as my primary backup system. And then I've got the ability that if my batteries get low, I can plug in the generator and top the batteries back up.
I
Sir?
have a quick question, unless you have a question too.
Okay.
I use it in my quota, I'm sure. No, back to batteries for a minute. So at a given amp hour, I'm seeing, the premium batteries like Trojan and all that expensive. And then you've got like Costco. Is there much of a difference in terms of lifespan and reliability between?
Yeah, well, I know for the Sam's Club brand batteries, the cycle life is about half of what the Trojan is for the same capacity. So it'll provide that capacity, but it's not as durable.
Okay. So you are getting something for that extra money.
Yeah, it really has to do with the thickness of the lead plates.
Okay.
And so that I think also correlates to the cost of the battery. So it's cheaper to produce a battery with smaller or thinner or more brittle lead plates. But that battery is not going to endure as many charge-discharge cycles as a battery with thicker, more durable plates.
What about solar panels tracking things that's not on the house, but like in your yard? You guys do that? How does that work?
We typically don't. So what she was asking about is the systems that allow the solar panels to track, to face the sun throughout the day as the sun moves, over the horizon. The economics of it just don't work anymore. It's more expensive to put in the pole mount and put in the tracking system than what it would cost to just add a few extra solar panels and mount to an existing structure like a roof. The tracking systems are quite expensive. The solar panels themselves are getting very, very cheap. The commercial panels now are about $175 a piece versus about $3,000 per pole for the trackers.
And how long?
About 250 watts.
And now we're close to 280 to 300 for the standard.
I'm just curious, you personally, how well do you do when we have like 5-7 days of cloudiness?
Yeah, I can't run my house for 5 days off battery alone. So if there's not sunlight coming in, I'll have to fire the generator, usually for 3 or 4 hours, get my batteries charged back up, and then I can run another 24 hours. Yes, sir.
Is there any interest, or do you have any experience putting wind turbines as a redundant charging source rather than a generator?
We have. We've done 2 systems that have both solar and wind power, and one of them has solar, wind, and generator.
Oh, okay.
It really depends where you are. The one system that has all 3 power sources is actually on the coast and Outer Banks, and they're in a position where they actually get good, constant wind all the time, and they're right there on the coastline. The other system we did was up in Winchester, where they do get some wind gusts here and there, but it's not frequent enough for it to be a reliable power source. So it's there, and it does put some juice in the battery, but it's just not a reliable power source. 95% of people are not in a suitable location for wind power. But if you're on a mountaintop by yourself, or if you're on the coast, like this gentleman is in Outer Banks, it makes sense.
How about your vertical wind turbine versus the other, the horizontal?
The vertical ones are even less efficient. I mean, you can put them just about anywhere, but they're even less efficient in terms of energy conversion. Sir?
I know they're making solar panels for metal roofing, where they literally roll on and stick to the roof. How long are those usually lasting?
We've never installed those systems. In fact, I think I'd have a problem getting the building permit passed on those type of systems. They're just not going to meet the wind rating as far as I understand. However, for a do-it-yourself type application, that might be a great solution. If you're just looking for something temporary, it's not going to stay on the property. I know a lot of folks use them for RVs too. Things they can park the RV, deploy the cells, and then just roll them back up before they leave.
There was one building that had basically put them all on the entire structure, and they have a 3-phase setup. So they're running the whole.
Is that here in Richmond?
That is here in Virginia.
Okay. I'd like to take a look at it, because if it is something that can actually get permitted, then that's an option that I'd like to make available to our customers. But right now, most of what we're installing is sort of your traditional aluminum frame, you know, crystalline silicone module, like what you see there.
What would that set up basically like that? You said those are 60s, right?
Yeah, these are 60-watt panels.
What would a setup like that cost?
I think I bought this setup for about $250 for just the panels there in the stand. And then depending on what type of controller and battery you get, you might be looking at another $200 for the controller and the battery, just for a basic 12-volt setup.
Probably about $500–600 that would be added additional panels. Okay.
Right.
Yeah, it's
Now
almost
that would
like
be
a
for a DC-only system. That would be for a DC-only system.
Yes.
Like for running mobile equipment.
Right.
So if you start adding in the inverter and then what it takes to hook an inverter up to your home system, you're going to be in the 2,000 plus range.
Yeah, it's mainly the portability that I'm referring to in my case. Since I have a generator, all that kind of stuff.
Sure. Any other questions?
Oh, real quick, I'm sorry. Bit of a tangent, you may not have an answer to this. You know if anybody's doing hydropower around here? I know if you have like a 10-foot head or so, you can get about 14 kilowatts. So.
I don't. Although what I can tell you is that if your site is proper for it, hydropower is the cheapest form of renewable energy, but you've got to have the right conditions.
You need strings.
All right. Well, I thank you all for allowing me to come and speak, and please let us know if there's anything we can do.
Yeah. Thank you, Joe, for your presentation.
I had a lady come in.
One more thing. We didn't have a 50-50 tonight, and we have a Frost Fest ticket. The only thing I think randomly could do would be everybody count off, and then we'll have someone related to the count leave the room, come back and give us a number. All
Yeah, that'll work.
right? Let's start count off. One, count off.
You want one? If you're one, I'll risk it. No, I'm joking.
Why don't we have somebody leave the room
Yeah,
and
that's
come
what
back
I'm
in advance?
Do you want it?
Why don't one of the girls
Yeah. What's going on?
leave the room, think of a number from,
Okay, Judy go? All right. Let's do it that way. That way this ticket won't,
My mom actually moved out.
yeah,
it'll be very random.
George, what are you doing?
giving away a ticket.
We have a Frost Fest ticket that Jim donated to the club, and we didn't have a 50-50. That was supposed to be one of the prizes, 50-50.
I already got a ticket, so.
All right, well,
So here we go. Count off.
go.
If you're not interested in it, don't give us a number. Count off and skip you.
The entire
It's getting more complicated.
Now, if you just need to run the a couple of sets
We all
like
can
this
count,
would be enough
so
to do
if you're not interested, don't be that number nine.